Our focus for today's lesson is going to be looking at converting between fractions, decimals, and percent. And so your learning target is going to be I can write equivalent values by converting between fractions, decimals, and percents. So moving fluently between the three forms is going to be our focus for today. So if we take a look at our solve and share, it says the grid is shaded with blue, orange, and yellow. What part of the grid is shaded blue? What part is shaded orange? What part of the grid is shaded, right? Each answer is a fraction, decimal, or percent. So I'm going to go ahead and I'm going to start with the orange. And so what's nice is it's symmetrical, so I just need to find it for the first shape and then multiply it by 4. So here I have 1, 2, 3, 4, 5, 6, 7, 8. So I do 8 times 4, and my fraction is going to be 32 hundredths, which is going to be equal to 32%, which is going to be equal to 32 hundredths as a decimal. If I look at blue, go up a little shade. Blue, again, I'm just going to go ahead. I'm going to find for one section 1, 2, 3, 4, 5, 6, 7, 8, 9. This one's going to be a little bit different. So let me go ahead and just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And the reason I counted on that one is because I crossed the middle. I didn't have a symmetrical design among all four. So it's going to be 20 hundredths, which then equals 20%, which then equals 2 tenths. And so notice I wrote it as 2 tenths and not 20 hundredths because it's still equal. If I wanted to, I could add that 0 and it would be equivalent. Okay. And it says what part of the grid is shaded. So if we take a look at the grid, everything is shaded. So the part of the grid that's going to be shaded is going to be 100%, which is going to be 100 over 100, which is going to be equal to 1. All right, so if we move into our look back, it says how are the decimal alike and how are they different? So if we take a look at a decimal and percent, they're going to represent the same value. So I have the same value. So 32 hundredths is representing the same value as 32%. But what's different about them is the decimal is in a different place. So the decimal is going to be in a different place. And so here my decimal is in front of the 3. Here my decimal would be after the 2. All right, so let's go ahead and move into your visual learning. And your visual learning says, each portion of time Teddy spends on homework is shown in the bar diagram. He spends 30% of his time on reading, 3/5 of his time doing math, and 1/10 of his time doing research for science. Fractions, decimals, and percents are 3 ways to show parts of a whole. Write 30% as a fraction and a decimal, and write 10% as a fraction and a percent. So if we start with our 30%, okay, so 30% is going to be written as 30 hundredths, which I can actually simplify that down because I can divide that by 10 and 10. And so I end up with 3 tenths. So I have 30%, I have 3 tenths, and then 3 tenths as a decimal would be written as 0.3. So here's my 3 forms that I would use. I would have 30%, 3 tenths, and 3 hundredths. For my fraction, what I would need to do is I would need to get to 100. So I would multiply these values by 20 to get to 100. And when I do that, I end up with 60 over 100, which would then be 60%. And then 60% would be equal to 0.6. Okay, so 3/5 is equal to the decimal 6/10, which is equal to 60%. And then my last one that I would take a look at would be the 1/10. So the 1/10 as a fraction, I write it as I say it. So it would be 1 over 10. And then my decimal was already written as 1/10. And then my percent, I would multiply the 1/10 times 10 to get to 10%. And so when I add all of these up, my percentages, they should all equal 100. So 30 plus 10 is going to be 40, plus 60 is going to be 100. And so I know that my percent calculations is correct for this problem. All right, so if we move down to the convince me, it says, what relationship do you see when comparing the equivalent decimal and percent? So if I compare 10 hundredths and 10%, what do I see as the equivalent? Okay, so we already answered this question. They represent the same value. So they are representing that part to whole relationship. If we move into your guided practice, we can also, so right here, notice that it says write 3/5 as decimal and percent. I can use division to find my decimal and then from there to find my percents. And so they did it with 3/5. I'm going to show you guys with 2/3 because 2/3 is not, 3 is not a number that goes easily into 100. It's not a factor. So I'm going to divide 2 by 3. So 2 is going to go inside my box. 3 is going to go outside my box. And so what I'm going to do is I'm going to do 3 goes into 2 0 times, add my decimal, add a 0. 3 goes into 20 3 times. That's going to be 18. I subtract. I have 2 left over. I add my 0. 3 goes into 20 3 times. I have 18. I subtract. I have 2. I add my 0. Goes in there 3 times. I'm hoping at this point in time you're recognizing the pattern. So it's 0.3333 repeating, so that above the line symbol is repeating. And so how I would write this as a fraction, I'm sorry, it doesn't go in there. It goes in there 6 times. Oh man, I was thinking of 1/3. It goes in there 6 times. So it's not going to be 33333 repeating. It's going to be a repeating decimal of 6. And so how I would write this as a percent is I would take my first 2 numbers. So I'm going to move this to the left 2 places. So I have my first 2 numbers, which is going to be 66, and then I do decimal, 6, and then I write it as a percent. Because percent means out of 100. So I take, if I have a 3-digit number, I take it, I multiply that by 100. And remember that when we multiply by 100, we move the decimal 2 places to the right. So my percent is going to be 66%. So let me go ahead and do one more as an example for you guys. I'm going to do 3 sevens. Okay, so I'm going to look at how many times 7 goes into 3. 7 goes into 3 0 times, put my decimal, add a 0. 7 goes into 30 4 times, that's 28. I'm going to subtract, I have 2 left over, add my 0. 7 goes into 20 2 times, that's 14. Subtract, have my 6. 7 goes into 6D. It goes in there 8 times. That's 56. Subtract. I have 4 left over. I'm going to go ahead and go out to the thousands place value so I can look at my rounding rules. 7 goes into 45 times, which is going to be 35. And so I'm going to go ahead and I'm going to stop because it's looking like it's going to be a non-terminating decimal. But if I take this and I multiply it by 100 to find the percent, I move this over 2 places. So I end up with 42 and 85%. So that would be my percentage that I would do here. Okay. So sometimes you're going to have to use division to find the percentage and to find the decimal because it doesn't easily multiply by a factor of 100. So let's go ahead and move into your guided practice. And it says, number 1, why can a fraction, a decimal, and a percent be written in equivalent forms? Well, the reason that they can be written in equivalent forms is they all represent a part to whole relationship. And in this case, they're all representing a part to whole relationship of 100. So that's why I can go ahead and write them into the 3 different forms. So in 2 through 4, write each number into two equivalent forms as fraction, decimal, or percent. So if I have it in one form, I'm going to go ahead and I'm going to write it in the other two forms. So 27% would be 0.27 as a decimal, which would then be 27 over 100. I look to see if I can simplify. 27 and 100 don't have any common factors, so I would not be able to simplify. Okay, so if I look at 91, it would be 91% and 91 over 100. Again, look at my fraction to see if I can simplify. 91 and 100 do not have any common factors, so I would not be able to simplify. 6 and 100, or 6 hundredths, would be 6%. And then my decimal here would be decimal 0.06. So because it's 600, the 6 needs to be in the hundreds place value. If I wrote the 6 in the tens place value, it would be equivalent to 60. So for your independent practice, I would like for you to go ahead and do problems 5 through 10. So you're going to do all of problems 5 through 10. And then your mathematic practices and problem solving, I'd like for you to do the following problems. I'd like for you to do 11, 12, 13. And then I would like for you to do 15. And I'd like for you to do 17. So the last problem I would like for you to do is going to be problem number 17. So you are not doing 14 or 16 in your math practices and problem solving.